Hello students, in our DME class, today we will discuss levers. So what is a lever first of all? A lever is a rigid rod or bar capable of turning about a fixed point called fulcrum. So lever is nothing but a rod, like this is a rod or a bar which is capable of turning about a fixed point. This is fixed point which is called fulcrum. It is used as a machine to lift a load by the application of small effort. So as you can see in this diagram, there is a load of 1 ton which is easily lifted by a man by applying a small effort on one side of the lever. The ratio of the load lifted to the effort applied is called mechanical advantage. So how much load and how much effort, the ratio of these two is called mechanical advantage. Principle on which the lever work is same as that of the moments. So for example, this is a lever AB. At point A, there is a load which is W and F is a fulcrum. At point B, you are applying a effort P and the distance of load from the fulcrum is L1 and the distance of effort from the fulcrum is L2. The points A and B through which the load and effort is applied are known as load and effort points respectively. So this is your load point, this is your effort point. F is fulcrum. The perpendicular distance between the load point and fulcrum means this L1 is known as load arm. Similarly, this L2 is known as effort arm. So according to the principle of moments, if we balance the moments about the fulcrum, so this is W into L1 and P into L2. We equate both of them, W into L1, P into L2, and find the ratio of load upon effort, which comes out to be L2 by L1. This load upon effort ratio, as we have discussed, is called mechanical advantage, which is also can be written as L2 upon L1. L2 is effort arm and load arm. So mechanical advantage is ratio of effort arm divided by load arm. It is also called leverage. Next thing is compound lever. A compound lever is a simple machine operating on the premise that the resistance from one lever in a system of levers will act as a power for the next. So in this case, the levers function in the same way as the simple lever, but the difference is that the resistance means, as you can see in the nail cutter, we have this lever here. We apply the effort at this point, but the resistance from this lever, the red one, goes to the blue one, transferred to the blue one, and then effort is applied on the second lever. So in this case, the effort is not applied on the lever directly, but the effort produces resistance and this resistance produces effort for the second lever. So in this case, it is called a compound lever. So levers are of three type. In the first type of levers, it is called first type only, first type lever. The fulcrum is between the load and effort. If your point F is between A and B, that is load and effort point, then it is first type of lever. Therefore, mechanical advantage obtained is more than one. In this case, generally, L2 is greater than L1. So mechanical advantage will be greater than 1. Examples are beam of balance, handle of a hand pump, etc. Like this is your beam of balance, fulcrum is between effort and load. Your hand pump, fulcrum, this point is between effort and load, are called first type of levers. Similarly, rocker arm ratio, fulcrum is between effort and load. So these are all called first type of levers. Now, second type of lever, the load is between fulcrum and effort. So the fulcrum is not at the center between effort and load, but load, that is point A, is between F and B. In this case, it is called second type of lever. Therefore, mechanical advantage is more than one. For example, wheelbarrow. So L2 is greater than L1. Therefore, mechanical advantage will be greater than 1 because mechanical advantage is L2 by L1. So example is wheelbarrow. As you can see in this diagram, this is your fulcrum here, this is load, and this is effort. So load is between effort and fulcrum. Similarly, this is your fulcrum, this is your load, and here you apply the effort. Opener, you can see this is fulcrum, this is load, and this is effort. So these are the types of second type of lever. Now third type of lever. In this case, effort is between the fulcrum and the load. So effort point, that is B, the P point is between the fulcrum and the load. Since the effort arm in case is less than the load arm, so effort arm, that is L2, is less than L1, therefore mechanical advantage is less than 1. In this case, we have to apply more effort. As you can see in this examples, the fulcrum point is here, you apply the effort is here, and load is here. So effort is between fulcrum and load. Or in this diagram, fulcrum is here, effort you apply here, and load is here. And when you pick the dumbbell, so this is your load, here you apply the effort, and this is your fulcrum. So the fulcrum is not at the center, but effort is between the fulcrum and the load. This is called third type of lever. So we have discussed types of levers: first class, second class, and third class. In first class, the fulcrum is between load and effort. Examples are pliers, first class lever. Second class lever, load is between fulcrum and effort, like wheelbarrow, second class. And in third class, effort is between fulcrum and load, like cranes, etc. Third class lever, effort between the fulcrum and the load. You can have number of examples as we have discussed in the previous slide. Okay guys, so numerical problem we will discuss in the next video. Okay guys, thank you.